Good morning. I have decided I will record the lab explanation of the lab program 1 so that that will be useful for your external lab exams of machine learning lab. Okay, so what is Findace algorithm? So Findace algorithm mainly it is used to finding a maximally specific hypothesis. For that purpose, first let me revise the things like what is given. Like the problem will be given here. I'll show you the problem first. Here we are given one data set that is called Enjoy Sport. It's a task. Okay, and it has the attributes sky, air temperature, humidity, wind, water, forecast, and enjoy sport. Here, sky, air temperature, humidity, wind, water, forecast, these are the features. And the concept which we are going to learn is enjoy sport. Okay, so this is the training set. So if we are given a test case, then we are going to find out whether, like what is meant by test case? You will be given the values of sky, air temperature, humidity, wind, water, or forecast. You are going to predict the value of enjoy sport. For that purpose, we are coming up with the hypothesis based on which you are going to find out whether that particular test case prediction is it yes or no. Okay. So before that, like what do you mean by all this? Like what is given, what we need to determine and all we will see. So here given is the instances. So what are the instances? These are the possible days which are described by the attributes. What are the attributes or features? They are also sometimes they are called features also. So one is sky, and this sky feature is having values. The possible values of the sky are sunny, cloudy, and rainy. And air temperature, air temperature, it has the values warm and cold here. Okay, and humidity with the values normal and high. Okay, let me use this pen instead of So the values are sunny, cloudy, and rainy. And air temperature, it has values warm, cold, and humidity with the values. These are the unique values I'm talking about here. If you can see here, the humidity, under the humidity, we have two unique values, normal and high. What the values of this feature or attribute, humidity are normal or high. Okay. Then wind has two unique values, strong and weak, and water, warm and cool, and forecast with the values same and change. And what is the hypothesis? So as you know, the hypothesis, it is described by the conjunction of the constraints on the attributes sky, air temperature, and humidity. Sky, air temperature, all these attributes we are talking about. Okay, the constraints on these attributes. What is the constraint? On the attribute sky, it can either take sunny, cloudy, rainy. Okay, these values, or it can be anything that is a question mark. Okay, so that is a generalization you can call, and this is null. That means no value will be acceptable with it for this sky. So what do you mean by that? So sky can take the values sunny, a specific value, sunny, cloudy, or rainy, or it may accept any value. There is no restriction. Okay, or else it will not accept any of the values. Okay, so these are the possible constraints on this value. Okay, then after that, like for if you are taking the air temperature, it can take specific value. What are the specific values here? Warm or cold, or it can be generalized. Any value is acceptable, or nothing, no value is acceptable for this air temperature. Okay, so now this hypothesis, what is the hypothesis? Hypothesis contains, okay, it is described the conjunction of the constraints. That means sky can be any value. So we are going to find out the hypothesis. This is an example. This can be, the sky can be anything, or air temperature must be warm. Okay, air temperature must be warm, or humidity can be like no value is acceptable. This is an example. Practically no value is acceptable will not get, okay, in a real life examples. And wind can be, suppose that is anything. Wind value can be anything is acceptable. Okay, then after that, the water, let it be cool. Okay, the specific value only as acceptable for this. Okay, then cool, then forecast can be anything. So that means after seeing all the, I mean, we are given a training set. Based on this training set, we are going to find out this hypothesis based on the training examples. Okay, now this hypothesis will be used to predict a new test case. What is meant by new test case? You will be given one example, like sky value is sunny. Okay, you are having a test case like the sky value is sunny, and air temperature is warm. Air temperature is warm. Then after that, humidity is some high. This is a new case you are talking about. Okay, so for which you are going to predict the concept value. It is high, and here this wind can be, suppose that wind is cool. Okay, wind is cool. This is cool. And after that, water is also, I mean, two question marks here. I forgot one more here. Two question marks are there. And here this can be the water is cool. Suppose this is also, no, something is wrong. High, then after that, sorry, this is only one question mark here, and here this is not there. This is strong. Okay, suppose that this is strong. Okay, strong. And here next thing is water is cool, and here this is cool, and next one is forecast is some change. Okay, so this is the new test case. New test case, you're going to find out whether the concept, I mean, here in this, we are going to predict that enjoy sport thing here. Okay, so here if this is the case, so how you are going to determine whether enjoy sport is, the concept is true or false, I mean yes or no. So how you are going to determine this test case? Based on the hypothesis. So what does hypothesis say here? This can be that the sky can be anything. So this is sunny, so now this is acceptable. Okay, so this is right, sunny is matching this with this hypothesis. And next, air temperature must be warm. Yes, this is warm. Next, humidity must be null. That means no value is acceptable. But here we are having the value high here. So this is not no matching with the hypothesis. Then after that, next is wind. Okay, so wind, for which you have a question mark. So here this is wind is strong. Okay, so this is also acceptable. This is water must be cool. Yeah, this is also cool in the test case. This value is cool. Okay, this is passed. And here forecast is change. It is written in the test case, and the hypothesis it is anything. So this is also passed. But since this is not matching with the hypothesis, this value is not matching, because in the hypothesis we came to, what is the hypothesis? We established the hypothesis based on the training examples. Okay, so that means the sky value is anything, or a temperature is warm, or no value is acceptable humidity. For humidity, wind is anything, water must be cool, and forecast is anything, then that particular training example is classified as a yes. Okay, otherwise anything, if it is mismatched, then it is not a I mean the value, the concept, the enjoy sport is no. So now we say that the value for the enjoy sport for this particular test case is no, based on the hypothesis. Now what are we going to do in this algorithm or program? We are going to establish this hypothesis. How you are going to find out this hypothesis? We are going to see this program. We are going to write the code for this. Okay, so suppose this is the training set. So here this is called enjoy sport task. As I told you, it has 6 features, 6 attributes, and one target value. What is the target value? Enjoy sport here. Okay, so the enjoy sport, it is no classification example. It can be either yes or no. Okay, only a few examples, few training examples have been given, and we are going to establish the hypothesis from this by using this algorithm is called find-s algorithm. Find-s algorithm. We are going to find the maximally specific hypothesis, which I have showed you in the example. So this find-s algorithm says that initialize H to the most specific hypothesis in H. What is most specific hypothesis? There are two things here. One is specific, okay, one is specific, okay, and the other one is called specific, and the other one is called general, okay, general. So here we have three constants, as I told you. Specific value, one is most specific value, that is nothing but null, that means no value is acceptable for that feature or attribute. Or general, so which is denoted by the question mark, which says that any value is acceptable for this particular for that particular attribute. Otherwise you can have the value like warm, cool, or strong, something like that. Okay, so first we are going to initialize h to the most specific hypothesis. So what is meant by most specific hypothesis here? How many? So you're going to write h, or that says it is a hypothesis, and within the parenthesis you're going to write the most specific values for each and every attribute. So here how many attributes are there? 1, 2, 3, 4, 5, 6. Okay, so 6 attributes you're going to for all the 6 attributes you're assigning this null values. All the null values will be written for this. So this is the first step. What is the first step? Initialize h to the most specific hypothesis in h. So this is the hypothesis space. H is nothing but capital H denotes the hypothesis space, which is nothing but which is nothing but the set of the hypothesis. And now initially we have assigned all the null values to this hypothesis. Okay. Next, for each positive training instance x. Okay, so here first of all, let me tell you, this find s algorithm, it only works for the positive training examples. It will not consider the negative training examples. I already told, I mean, we had discussed this in the candidate elimination algorithm also. In that video also I had explained that the problem with the find s algorithm is it deals only with the positive training examples. It will never consider the negative training examples. Okay, so here the second step is for each positive training instance. So how do we find whether it is a positive or a negative? If you test this, okay, the value of the enjoy sport, if it is yes, that is a positive, okay, positive example. Otherwise it is a negative example. So that means we are going to consider only 1, 3 and 4 here. We are not 1, 2, sorry, 1, 2 and 4 here. 3 will not consider, will not be considered. So what are we going to do for each positive training instance x? So what is meant by instance? So this is called instance. That means the values of all the instances, all the features, it is called instance. For each instance, for each positive training instance x. Okay, so this is x here, this is x here. So what are we doing? For each attribute constraint ai in h. Okay, so if the constraint ai is satisfied for each, so each attribute constraint in ai in h, the constraint ai is satisfied by x, then do nothing. So what do you mean by that? Here, what is the constraint here? I think you have this in this. Okay, so here first we are going to consider, what is the hypothesis? As we had initialized everything to the most specific hypothesis, this is all the null values will be there in H. After that, first instance, that is nothing but sunny, warm, normal, strong, warm, and same. And this is the positive instance. So that's why we have taken all the values in the angular brackets, and this plus indicates that this is the positive example. Now, so what is the first step in the algorithm? If the constraint is satisfied by x, do nothing. So what is meant by that satisfying here? Here, if you observe the first training example, you observe that this is too specific. So what is meant by that? Here null value is there, but here if you observe, when you take this x1 into consideration, you see that this is very specific, most specific. So what do we do? Wherever there is a null value, that will be replaced with the value, the specific value. You make it's kind of a generalize. Okay, what is meant by that? It cannot be a null value, it can be a specific value. What is that specific value? Sunny. So wherever there is a null, you change it to sunny, and here this is null and this is warm, this is, so this will be replaced. All the null values will be replaced by the values in the first instance. Okay, so the null value, each null value will be If there is a change, if there is both are same, that is fine, you can leave it. Otherwise, if it is most specific and this is specific value, then you have to change the hypothesis. That is the most next more general constraint, that is H1. You are making it to this null and sunny, because this is null more specific and sunny will be written, and warm, normal, strong, warm and same will be written. Okay, so and this is still specific. So you're going to consider the more training positive example. The second one is also the positive example. Okay, so that's what you are doing it here now. So otherwise, what you're going to do, if AI is satisfied by X, both are same, then do nothing. Otherwise, replace AI in H by the next more general constraint that is satisfied by X. That's what we have done. Okay, so this will be for each positive training example, you're going to repeat that. Okay, consider the next training example. Next training example, what is that? Is first you need to check whether it is a positive or negative. This is a positive. Okay, consider this training example next. Okay, consider this training example next. Okay, so and this is yes, so you're going to consider sunny, warm. Okay, so write down that x2 is equal to sunny, warm, high, strong, warm and same. This is also positive, that's why it is written plus symbol there. Okay, now you have to compare this H1 and X2. Okay, whether they are both are satisfying or not. Here this is sunny, so you have to compare both. Okay, so this is sunny, this is also sunny, so there is no change as per the algorithm. This is warm, this is also warm, so there is no change here. But the problem here, I mean, here it says the hypothesis says it is normal, but in the positive training example, in the training set, it says it is high. So that means here we need to, whenever there is a change here, it is some the values are changing, then that constraint will be replaced with the question mark. That means any value is acceptable. It can be now normal, it can be high. But as you know, like one of the constraints is question mark, and question mark is nothing but any value is acceptable for that particular attribute. Okay, then here this is strong, this is also strong, so there is no change. And this is warm, this is also, there is no change. Same and same, no change. So now the hypothesis will be changed to this. Okay, so the same, but here only one question, we have added one question mark because this is not satisfying with this. Okay, so that's why we are putting the question mark. Next, consider the third training example here. What is the third training example? Here this is nothing but rainy, cold, high, strong, warm and no. And because this is a negative training example, we are going to consider that negative training example. Okay, so as per the finders algorithm, we need to consider only the positive training examples. Okay, then it will not consider this, it will just ignore it. Okay, so then what will be the hypothesis? Now H3 will be the same because we haven't considered this. Okay, now go to the next training example. This is the fourth training example. Okay, which is sunny, warm, high, strong, cool, change and S. This is a positive training example. We need to consider that. Okay, so here H3 is this and X4 is this. Okay, now both values are same. Okay, don't consider, I mean, don't consider, I mean, it will not be changed. Warm and warm, it will not be changed. Here this is question mark, this is high. That means once question mark is more general, and any, what does it mean? Any value is acceptable for this attribute, so it will be question mark. Next, this is strong, this is also strong, so it will remain the same. And here warm and cool, so this is warm and this is cool, so it is different, the values are different, that means it will be generalized. And same and change, here also the values are changing, it will be more generalized. Okay, now since this is the last training example, we had seen that now we had established the hypothesis. What is the final hypothesis? Final hypothesis is sunny. Okay, sunny, then warm, question mark, strong, question mark, question mark. Now, if you come across any test case, okay, what if the new test case, let it be, here we have, these are all training set. Suppose fifth one, we have a test case and this value is sunny. Suppose this is sunny and this is cold and this is normal. Okay, this is normal and this is strong, this is strong, and this is suppose this is cool, okay, cool, and this is same. What will be the value of the enjoy sport, whether the some particular person can enjoy the sport or not? That this is what you're going to find. So you're going to consider that hypothesis. What is that hypothesis? What is the final hypothesis we got? This one: sunny, warm, question mark, strong, and question mark, question mark. Okay, so that means first one is, what is the value of the sky? Sunny. So in the hypothesis, okay, let me this sunny, warm, sunny, warm, question mark, I'll write this there. So the hypothesis which we established is sunny, sunny, then warm, then question mark, then question mark, strong, question mark, question mark, strong, then next question mark and question mark. Okay, so now this is sunny, so it is matching in the with the test case. Cold and warm, yeah, here this here is a contradiction. Here any value is acceptable, so this is right. And storm, any value is acceptable, this is also proper. And here this is cold and strong, here again this is the contradiction. This can be anything. So because this is not matching, these two are not matching, cold and here this is warm. So these two are not matching, then we classify this particular test case as negative. Okay, so wherever it is matching, if the test case is matching with the hypothesis, then only we calculate, we predict that particular test case to be positive. Otherwise, any constraint is mismatched, then it is classified into or predicted as a negative example, that is no. That the enjoy sport value, we conclude that this is no. Okay, so this is about find this algorithm. So we are going to implement, how you are going to implement this in Python. Okay, before that, let me tell you, I have a blog, okay, on GitHub. So where I had posted, I had given the link of a GitHub link of Avinash, who is passed out 2016 student, 2016 batch student. He has all the lab programs has put in the GitHub account. We can, if you want the codes of these lab programs, you can go through. I mean, you can go to his GitHub and you can download programs, code for the programs. So all this. There is, yeah. So all the programs are there. The code, all the programs is given, and also corresponding is also okay. One second, give me a second. Some internet problem. Okay, so this is the data set. Okay, so it is very slow. This is the lab program. Yeah, this is the lab program. Okay, so you can copy the code from this. Okay, and yeah, and you can either use, yeah, you can either use Spider or Jupyter Notebook also, no problem. But I do prefer, I mean, during the lab, externals and internals, you're supposed to use Spider. Okay, so now I had already typed and kept the program in this Spider IDE. Okay, so how you're going to do, you have to select a new here. Okay, if you want to keep, otherwise you can remove all these things and start writing the code here. Okay, so after, one second, I will change this name to program1 .py. Yeah, you need to give the extension as .py because it's a Python program. Okay, so then save it. So you can see here the program1.py, it is mentioned there. Okay, and also if you, I mean, if you, the data sets will be provided and it will be kept in D drive, that path will be provided where the data set is kept, that will be provided to you people in the lab. Okay, you can take the data set, you can take the data set from there. Okay, otherwise if you have any problem with that data set, you can create a new file here itself. Okay, and if it is a small data set like enjoy sport and all, you can type it here. Okay, like this, you can type it here. This should be the CSV file, that is comma separated values, so everything should be separated by commas, by using commas. Okay, so this enjoysport.csv I already made, and this is here. Okay, now this is the data set which we are going to use for this program 1, which is find S algorithm. So here in the find S algorithm, okay, I'll just clear it. Yes. Clear. What is the, okay? Yeah, clear is the correct command. Okay, so now in this program, we are implementing that particular find S algorithm. For that purpose, we are first what? Let me. Okay. Okay, so here we are going to import these pandas as PD. We are going to use this pandas library, so that we use. I mean, this is a library which will be used especially for this in-dimensional arrays and all. Okay, so we are going to, why we are using these pandas? We are going to use that data set as a in-dimensional array in this program. So for that we are importing these pandas to this program. Okay, and here, I mean, here it will start it will start executing from here, right? So what is this? This is the function call. Find S is the function call. Then the control will be transferred to this particular function find S. Okay. So in find S, what are we going? I mean, you know, like this is a user defined function. Find S is the name of the function. We are not sending any parameters to this particular function. Now, so what is the name of the data set we are using? Enjoysport.csv. So here, and remember, if they are in the same space, same path, there is no need to enter. There is no need to specify its path. Okay, so directly you can use this enjoysport.csv. You can use the name file name. Otherwise, if it is in some other path, then you have to specify the whole path here. Remember, okay, and you're going to read the CSV. Read underscore CSV is a function method which reads the CSV file into this data array. Okay, then after that, what we are going to do? We are going to convert all this into list. So whatever the values are there in the data array, we are going to convert the list. So now, if you have any problem, like if you are getting any error or something, so it is always advisable to use these printf statements after finding out something, like after finding the value of data array. What is that data array value? You can use that in the printf statement, inside the printf statement, to see what is happening here. What is it like? What is the values in the data array? So if you see here, so this is the data array. So what is this data array? Here, this data array contains a list of lists. What is meant by list of lists? A kind of a array, right? So here, first one is the, if you see, this is a list of the enjoy sport, sky, air temperature, humidity, wind, water, and forecast. If you see these are the headers. Okay, so these are the column headers, feature names. So that will be the list here. That will be taken as the list here. And here next, in the enjoy sport only, next is yes, sunny, warm, normal, strong, warm, and same. So this is all these lines are taken as a list, and all these lists are contained in one more list as far as this is concerned. Okay, so now I'm just putting this as a comment, so that, I mean, it's not required, only to check what is happening with these values. Okay, then after that, as per the algorithm, we are going to initialize the hypothesis, the hypothesis as all the null values, because there is no provision for using that null this zeros like this. Okay, so here all these will be kept in the I mean double quotes. This is we are initializing the initial hypothesis. The initial hypothesis will be this. Okay, now I just wanted to find out what is the how many number of rows are there in this. Okay, so here you can also check here. So how many number of rows it is giving us. Okay, and I want to print here what is that value I'm going to print. Okay, to know that I'm just writing rows like this. Okay, yeah, number of rows is 5. Okay, so here 1 2 3 4 including the feature names, the number of rows will be 5. And here manually we had given columns is equal 7, otherwise you can use some method or some calculation, but here we have written this columns is equal to 7. Okay, after that what is the next step in this, for each row in this. So for each row in this we are going to take the positive examples only. So that's why we are writing for x in range of 1 to rows. So why we have, what is the number of rows here? 5. So 1 to 5. So here why 1 it is not 0, because we are not going to consider this enjoy sport, the column head. We don't need the feature names here. We are going to consider only this. So that's why it is starting with 1 only. Okay, so 1. Now T is equal. Now what you are going to do? T is equal to, first you have to extract the first training example. So what is to extract the first row in the this one. So first row is nothing but S Sunny. Okay, I'll just maximize this only to, yeah. So far is the first row, yes, sunny, warm, and same. Okay, and here remember in the previous examples I have shown this enjoy sport at the end, and here the target value is in the beginning only. So this is the target value, these are the features. Okay. So here T is equal to data array of X. That means we are extracting this value. Okay, so what is that? S up to here we have to extract this. So that will be stored in this T. If you want, you can check here by using the print statement. As I told you, wherever you want, you can print use a print statement to check the values here. So this is T. Okay. Yeah. So first T will be the first one. Yes, sunny, warm, and all. Next, if you can check the last row, it is yes, sunny, warm, high, strong, cool, and change. So each time for all the rows except the first row, which is the column head, feature names, we are extracting all the remaining 4 rows here. Okay, so this T is used for. Okay, let me use this as a comment. Okay, next, how do you know whether that particular training example is positive or negative? So here this is the first value, the first column, first attribute is the target attribute. So we can write if columns minus 1 is equal to 1. Oh, I'm sorry, I'm using another data set, not this enjoy sport. Minus 1. Okay, some other. There are 2 enjoy sports here. This is the one. We will just put here copy. Column is equal to 1, it is showing. Columns minus 1 is 6th one. Is 1. Is it changing 1? No. How come it is happening? Enjoy sport.csv. This is totally different. This is not the 6th one. Same and all it is taking. So are we getting the, oh yeah, right. So whatever the output, we are not getting it properly because the this one is wrong. Okay. So what we are going to do is we are going to change this into, so here Here in the enjoy sport, this is the first column, right? 0th column value only we are going to check here, and this is yes or no. So let us change the program now. So this, if it is yes, and that also it is column value is 0. So you can, I will write directly 0 here, and I'll just check. Okay, let me check this. Here this is yes. Okay, and first let me save this and run the program. If it is proper, then I can go ahead. Are we getting the same? Somewhere it is wrong. Yes, sir. Okay, so it is not, it is taking yes. Okay, so this is 6, and this is taking the first value, and the last value is missed out. So here we, here what we had to do is you had to change the values. The whole code has to be changed because I had changed the data set here. So for range of, okay, let me save this and again run. Okay, so somewhere is wrong. Columns, ranging columns -1. Still it is null value is coming in range of columns -1. Huh.